Welcome to the deep dive. Today, we're going to take a deep dive into something that, well, it sounds like science fiction, doesn't it? AI that can write code.
It's pretty mind-blowing.
You've got all these research papers, tons of them, about these large language models,
LLMs, yeah.
LLMs, right? That are, well, they're changing how we think about programming, I think.
Yeah,
I'm
definitely.
talking codecs, GPT, systems that can write code, but not just that.
Passing professional exams.
Yeah, it's wild.
It really is pushing the boundaries of what we thought possible. These models, they're trained on a massive scale, like absorbing millions of lines of code, all this text, learning to see patterns and relationships, stuff even their creators didn't expect.
So before we get into the nitty-gritty, can you give us the elevator pitch on what large language models even are? How do they work?
Okay, so imagine this huge digital library, right?
Yeah.
Packed with books, articles, code, basically all the text you can find online.
I'm picturing the Library of Congress, but digital.
Even bigger. So large language models, they're trained by basically living in this library. They learn to predict what word comes next in a sentence.
Kind of like how we learn language, right?
Yeah, exactly. But on a scale that our brains can't even fathom.
So they're absorbing, what, all of human knowledge?
Well, all the knowledge that's been digitized, at least. And from that, they can generate all kinds of stuff.
Poems, code, whatever you want.
Pretty much.
We got codecs here. This one's like the rock star of code writing, right?
Yeah, Codex is special.
What makes it so special?
Well, it was designed specifically to write code, right? Researchers took a massive amount of code from GitHub.
GitHub, like the code hangout spot.
Exactly, the world's largest open source code repository.
Yeah.
They used all that to train Codex. So what you get is this AI that can take your instructions, written in plain English, and turn them into actual working Python code.
So I could say, write me a program that sorts a list of numbers, and it would just do it.
Yep. And what's amazing is how well it does on those, standardized coding tests. There's this data set called Human Eval, meant to challenge even experienced programmers.
Tough stuff.
First try, Codex solved almost 29% of the problems.
Not bad.
But here's the thing. With more tries, it got over 70%.
Whoa, hold on. That jump from 29 to 70, that's huge. Does that mean it's learning as it goes, like a human programmer would?
That's what it looks like. It's not just memorizing code. It's reasoning about the problem, coming up with different solutions, adapting, that's pretty high-level learning.
Okay, so now the big question, can AI like this replace programmers?
Everyone's asking that. But it's not that simple. These are tools, right? They could automate things, but they can't do the creative problem solving, that design thinking that humans bring. Not yet, anyway.
Okay, so maybe not replacing us, but definitely changing things up. And it's not just Codex, right? We've got GPT-4 here too. This one's more of a multi-talented AI, right?
Yeah, GPT-4 is super versatile. It can do so much. Writing different kinds of creative stuff, translating languages, answering your questions like a pro. But here's what got me. It's passing professional exams. We're talking top percentiles on tests like the SAT, various AP exams, even the introductory sommelier exam.
Wait, sommelier, so this AI can write code A&D, tell me what wine goes with my fish tacos.
Exactly. And it's not being fed the answers, right? It's drawing on this huge knowledge base, textbooks, articles, pretty much anything you can find online.
So it's learning from the same stuff human students would, but way faster.
On a completely different scale.
It's like the ultimate study guide, but one that can actually think and apply what it knows. And here's another wild thing from the GPT-4 paper. It can process images. It's not just text. So theoretically, you could show it a chart or a graph, and it could analyze the data.
Exactly. That opens up so many possibilities for how these models can be used.
Yeah.
Medical images for diagnosis, architectural plans, even artwork, you name it.
Wow. It's like we're on the verge of something massive here. But this brings up big questions, right? If an AI can write code, pass exams, what happens to education? What happens to jobs?
It's a really fascinating time, and we're just starting to grasp what these technologies can do. But it's definitely a crossroads. We need to think carefully about how we develop and use these tools.
The potential is huge, but we've got to consider the implications.
Absolutely.
Okay, so we've talked about what these models are, the amazing things they can do, the big questions they raise. But how do they actually learn? What's going on under the hood, technically speaking?
The training process is complex, but it's basically repetition and reinforcement. They're exposed to tons of data, and they learn by trying to predict what comes next in a sequence. For example, Codex was trained on 159 gigabytes of Python code. That's a lot of code.
Yeah, more than I've ever seen in my life, probably. And GPT-4's training data is even bigger, right? Although they keep the specifics hush-hush.
Very hush-hush.
Yeah.
But even with all this data, it's not just letting the AI run wild. There's human guidance involved.
So it's not a completely hands-off process.
No, definitely not. There are techniques like supervised fine-tuning, where the model's given examples of correct output and it learns to copy that. And there's reinforcement learning from human feedback, where human feedback is used to refine the model's performance.
So it's this combo of algorithms and human expertise guiding these models to be more accurate and sophisticated. Which reminds me, there's this other interesting detail. These models are mainly trained on English data, right?
Yeah, mostly.
But even a little bit of data in other languages lets them do some pretty impressive multilingual stuff.
It's like they can figure out the patterns in one language and apply them to others. It's wild how fast they pick up the nuances of different languages.
It's like they're tapping into the core of language itself, something that goes beyond individual languages. But this brings up a question. If they can learn so much from such different sources, are there limits to what they can do? Could biases in the data itself, could that affect their output?
That's a crucial question, and researchers are definitely looking into that. The data used to train these models is super important, and people are realizing that we need more diverse and representative data sets to avoid potential biases.
So it's not just about building bigger, more powerful models. It's about making sure they're trained on data that reflects, the real world in all its complexity.
Exactly, and that's a conversation that needs to keep happening as these technologies keep evolving. We got to be careful to spot and address potential biases so we can build AI systems that are fair, equitable, good for everyone.
Right.
Yeah. One thing that stood out to me going through these papers was how detailed they get when they analyze what these models can do. It's not just, hey, look, it writes code. They really break it down, like how it works, what it's good at, what it struggles with.
That's what I love about good research. It's not just about the results, it's about the process, right? All the little details. So what did they find out about Codex, digging deeper like that?
Well, for example, they mentioned that Codex has some issues with instructions that are like long chains of things. Like it's better at sort this list than something with multiple steps, things that depend on each other.
Makes sense. Even for us, breaking down complex stuff into smaller parts, that's key. Things like AIs hitting some of the same walls we do.
Yeah, totally. And they found it can sometimes struggle with binding operations to variables,
Yeah.
which is a pretty basic thing in programming.
Right.
It's cool to see where they trip up, though. It tells us something about how they're learning, processing information.
It's like watching a kid learn to walk, right?
Yeah.
You see the stumbles, the falls, and you realize how much goes into every little thing. It makes you appreciate how complex learning is, whether it's our brains or an AI's neural network.
Exactly. And I think that's easy to forget when we see those headlines, AI passes exam or whatever.
Yeah.
We're still early in this. These models, they're work in progress.
Definitely. But they're learning fast. Which brings up another thing from the research. They put a lot of emphasis on functional correctness. It's not just about the code looking right, it has to work.
Totally. You can have code that's syntactically perfect. All the rules of language are followed,
Yeah.
but it doesn't actually do what it should.
It's like a grammatically perfect sentence that makes no sense.
Yeah. So they really focused on testing if the code works, not just if it looks pretty.
So they're giving these AI models real coding challenges and then running the code to see if it spits out the right answer.
That's the gist, yeah. Much more rigorous way to see what they can really do. It's like the difference between memorizing a textbook and actually solving a real-world problem, right?
Love that analogy. And that focus on it actually working, that's got to be key. If we ever want to trust AI to write code we depend on, it can't just generate code, it has to solve the problem.
Exactly. Reliable, robust, not just surface-level stuff. But let's, zoom out for a second. Think about what this means for someone listening. Someone hearing this and wondering how this affects them.
Okay, yeah, let's bring it back down to earth. If you're a programmer, this research is probably both exciting and maybe a bit scary.
Yeah. Exciting because these tools, they could make your life easier, right? Help you code faster, more efficiently. Imagine having an AI assistant that takes care of the boring stuff, like writing boilerplate code or finding bugs in those tricky functions.
Like a superpowered intern handling the grunt work while you get to the fun stuff.
Exactly. But I get why some programmers might be a little freaked out too.
Yeah, that whole robots taking our jobs thing.
Totally. But remember, these are tools. They help us, they don't replace us, at least not yet.
Hmm.
We still need that human ingenuity, the creativity, the problem solving.
It's more about adapting, right? Learning to work alongside these AI tools, using their strengths while knowing their limits. It's a new kind of teamwork, I guess, one that could change what it even means to be a programmer.
Definitely. And for people who aren't programmers, they might think this research is like too technical, doesn't apply to them. But the truth is, this tech is going to have a ripple effect everywhere, every industry, every part of our lives.
Yeah, AI that can write code, that's a game changer way beyond just software. Think about healthcare, education, finance, manufacturing, anywhere you have complex systems and tons of data.
Exactly. Imagine AI tools that personalize how you learn, develop new medical treatments, make energy use more efficient, even create new art and entertainment. The possibilities are huge.
So even if you've never written a line of code yourself, this is something to pay attention to. It's shaping the future, and we all need to be part of the conversation. But as we said before, with great power comes great responsibility, right? We need to be careful with this stuff, make sure it's used ethically.
Absolutely. Yeah. It's not just about what these models can do, it's about how we should use them. Which brings us to this whole conversation about, like, responsible AI development.
Right, we've talked about the amazing stuff, the potential, but there are downsides too. We got to be aware of those.
One thing researchers are really focused on is control and transparency. As these models get more complex, it's important to know how they're making decisions
Hmm.
and to make sure those decisions, like, match up with human values.
It's like teaching a kid right from wrong.
Yeah, we want these AI systems to be smart, but also ethical.
Exactly. It's not just about preventing the bad stuff. It's about making sure this technology is used to help people, to make things better.
Exactly. And that means thinking about bias, fairness, accountability, making sure these systems don't just repeat existing inequalities or create new ones.
Right. We need to be building these systems with ethics in mind from the start,
Yeah.
not trying to fix things after they've gone wrong.
Absolutely. It's about building AI that aligns with our values, AI that we can trust to make fair, transparent decisions that benefit everyone.
And that's going to take collaboration, right?
So
Researchers, policymakers, ethicists, the public, everyone needs to be involved.
it's a conversation for all of society.
For sure. Because in the end, the future of AI, it's not happening to us. We're all creating it together. And the choices we make now, they determine what that future looks like. But let's shift gears a bit. We've been talking big picture, but what about the day-to-day? What's it actually like to work with these AI tools?
Well, one area where we're already seeing a big impact is software development. These code-generating LLMs, they're being built into the tools developers use, making it easier and faster to write code, debug errors, even write documentation.
It's like having coding superpowers, right?
Yeah, kind of. Like, you're still typing, you're still in control, but everything you do is, like, amplified, enhanced. And it's not just about speed. These tools can help developers write better code, suggesting improvements, finding potential bugs, even enforcing coding standards, like a digital mentor, guiding you to do things better.
So it's not just automating the boring stuff, it's actually making programming itself better.
Right. And it's not just for the pros either. These tools could make it easier for people who are new to coding to learn. Imagine an AI assistant that walks you through the basics, gives you feedback on your code in real time.
Like a personal tutor, but for code.
Exactly. And it's not just individuals. These tools can help whole teams work better together. Imagine developers and AI working seamlessly, each doing what they're best at, to create software that's more robust, more innovative, more user-friendly.
It's like an orchestra. Different instruments all working together to make this beautiful, complex piece of music. Except instead of instruments, it's humans and AI contributing their expertise to the overall creation.
I love that. And that's the point, right? It's not about replacing humans with machines. It's about finding new ways to work together to make each other better.
Absolutely. So we've talked about software development, but what about other fields? We mentioned healthcare and education, but can you give us some concrete examples of how these models are being used out in the world right now?
Well, in healthcare, we're seeing them being used to analyze medical images, like X-rays, CT scans, helping doctors with diagnosis. They're also being used to create personalized treatment plans based on a patient's genes and medical history.
So it's not replacing doctors, it's giving them better tools to make better decisions, to give better care.
Right. And it's not just about treating what's already there. These models are being used to develop new drugs, new therapies, by analyzing tons of genetic data, clinical trial data, all that stuff.
It's like having an army of researchers working 24/7 to find new ways to heal people.
Exactly. And it's not just about finding cures, it's about making healthcare more accessible. Imagine AI tools that can give basic medical advice, triage patients, even do remote consultations.
That would be amazing for people in rural areas, places where it's hard to see a doctor. It's like democratizing healthcare, making it available to everyone.
Exactly. And that's just the start. We're seeing this kind of stuff in education, finance, manufacturing, everywhere. Personalizing learning, developing new financial products, optimizing supply chains, even creating new art forms. It's everywhere.
It really does feel like we're on the edge of a whole new world.
And a world full of, like, both amazing possibilities and potential dangers, right? We need to be cautious, but also excited about what these technologies can do.
Yeah. Because at the end of the day, the future of AI isn't set in stone. We're building it. And the choices we make now, they determine what that future looks like. But I'm curious, from your perspective as an expert, what gets you most excited? Where do you see the biggest potential for good?
That's a great question. I think one of the things that excites me the most is the potential for AI to help us solve some of the world's biggest problems, climate change, pandemics, inequality. These are huge interconnected problems, and we
Yeah.
need new ways to think about them, to solve them.
It's crazy, right? We're talking about AI that can write code, but it's making us think about, like, what is creativity? What does it even mean to be human, when machines can do this stuff?
It really flips things on their head, doesn't it? These
Mhm.
technologies make us rethink things we thought were like basic truths. Like if an AI can write code that's not just functional but elegant, does that make what human programmers do less impressive?
Yeah. It's a question. Artists, philosophers, they've been debating this forever. Every time some new tech comes along and it seems like, oh, is this the end of human creativity? Photography did it, synthesized music, CGI. Every time.
Yeah, and there are no easy answers. But I always come back to, well, AI right now, it's a tool, a super powerful one, for sure. But in the end, it's an extension of what humans can do.
Right.
It's not like creating from nothing. It's building on what we've already done.
Like, I don't know, a painter with a new kind of brush.
Yeah.
Or a musician with some crazy new instrument. The tool itself doesn't make the art, but it can change what's possible.
Exactly. And just like any tool, AI can be used to create things that are good or bad, right?
Yeah.
Beautiful or destructive. It all depends on the person using it.
So if we're going towards a future where these AI tools are everywhere, then we got to make sure people know how to use them right. It's not enough to teach the technical skills. You need, like, critical thinking, too.
Oh, absolutely. Critical thinking is going to be so important. Being able to look at information, figure out if it's biased, think about the consequences of not just what we do, but what the AI does.
And it's not just about the tech itself, right? It's about the bigger picture. How will this change jobs, social structures, the way we learn, interact with the world? It's a lot.
It is. It's multifaceted, but I think the way to approach it is with curiosity. Openness, not fear. This stuff is here to stay, so how do we use it for good? How do we minimize the risks?
And that brings us back to that idea of AI as a partner, right?
Yeah.
Not something to be scared of or, like, worship, something to understand, to work with.
Exactly. And I think the key to making that partnership work is, well, recognizing what each side is good at. Humans, we're great at creativity, empathy, critical thinking, ethics. AI, it's amazing at pattern recognition, data crunching, speed.
It's like a dance, back and forth, each partner taking the lead when it makes sense. AI can handle tons of data, see patterns we miss, but we interpret those patterns, decide what they mean, what to do about them.
And that's where the really cool stuff happens. When you get human ingenuity and AI working together, you can do things neither could do alone. Solve problems that have been around forever, create new art forms, push the limits of what's possible.
It's kind of scary, but also, wow, it's exciting. We're at the beginning of something huge, and it's up to us to make sure it's a good thing for everyone.
Well said. I think that's a perfect way to wrap things up. This deep dive, well, we've covered so much, and yet we've barely scratched the surface of this whole world of code-generating AI.
From how it works to the ethics, it's clear this tech is going to change things big time.
But it's a change we can be a part of shaping. By having these conversations, doing the research, working together to use these tools responsibly, we can create a future where AI helps us, not replaces us.
A future where tech makes us more human, not less.
Exactly. And with that, thanks for joining us on this deep dive. We hope you learned something, thought about some new things, maybe even got a little inspired.
And as always, keep learning, keep asking questions, Be a part of this.
Until next time, keep exploring and keep pushing the limits of what's possible.